We're going to start talking about geometry by looking at some definitions and some notation that goes along with those definitions. Geometry is something that's included in many of the grades in the Common Core State Standards. Here's an example of a 4th grade standard that parallels what we're going to be looking at right now. So our first definition is of a point. It's an exact location with no size, just a position. And we designate a point by drawing a dot, and we can name a point with a capital letter. So in this case, this is point A. A line is determined by 2 points. It has no thickness and it extends forever in 2 directions. So a line is actually a one-dimensional figure. Here's an example of how we might depict a line. This line goes through points A and B, so we could call this line AB, or we could call it line BA. Collinear points are points that are on the same line. So if you look at the illustration up above, points A and B are considered collinear. A line segment is a subset of a line, so it's a part of a line that contains 2 endpoints and all of the points in between those endpoints. This would be line segment EF or line segment FE. You'll notice that a line segment is named by the endpoints that are contained in the line segment, and we can name that line segment in either order, EF or FE. A ray is also a part of a line, but it contains one endpoint and all the points on one side of the endpoint. So in this case, you can see that the ray contains an endpoint at point D, and then all of the points to the left of that on the line are also contained in this ray. Now, because rays only go one direction on the line, we have to be a little careful about how we name them. In this case, this would be ray DC. When we name a ray, we're going to be naming the endpoint of the ray first, and then the other letter that designates the name of the ray is any point that is on the ray. Intersecting lines have exactly one point in common. So in this case, we have 2 lines that intersect at point E. Parallel lines are in the same plane and they have no points in common. In this case, we have line CD and line MN that are parallel to each other. A plane is determined by 3 points. It has no thickness and it extends forever in all directions. So a plane is a 2-dimensional figure. This would be plane beta. Coplanar points are points contained in the same plane. So any points that are in the same plane can be called coplanar. Coplanar lines are lines that are contained in the same plane. Skew lines are lines that can't be contained within the same plane. These can be a little difficult to imagine, so let's think about a rectangular prism, a box. If we have lines that are on the bottom front edge of that rectangular prism and the top right edge of that rectangular prism, you can see that those 2 lines will not intersect, but they also are not contained within the same plane, so they would be considered skew. Concurrent lines are 3 or more lines that intersect in the same point. So if you imagine this rectangular prism again, and we have a line that is containing the bottom front edge of the cube, and one that contains the right bottom edge of the cube, and another one that contains the right front edge of the cube, those 3 lines intersect in exactly 1 point, so they would be called concurrent. Angles are formed by the intersection of two rays, and quite often we measure angles with a protractor. So we might measure an angle and consider it to be an acute angle. That would be an angle that has a measure that is between 0 and 90 degrees. A right angle has a measure of exactly 90 degrees. And lines and line segments and rays which intersect at 90 degrees we can call perpendicular. An obtuse angle measures between 90 and 180 degrees. And a straight angle measures exactly 180 degrees, so it forms a straight line. Now when we measure angles with a protractor, we're measuring to the nearest degree. But we can actually measure with a little more accuracy than that if we subdivide the degrees. So a degree can be broken up into 60 smaller pieces called minutes, and a minute can be broken up into 60 smaller pieces called seconds. So in 1 degree there are 60 minutes, and in 1 minute there are 60 seconds. So let's suppose we have two angles that were measured very precisely in degrees and minutes and seconds, and we want to add those two angle measures together. Well, what we're going to do is look at the smallest unit of measure we have first, which is the seconds. We have 42 seconds plus 51 seconds, which gives us 93 seconds. But we could regroup 60 of those 93 seconds together to make a minute. So the 93 seconds is really 1 minute plus another 33 seconds. So we'll write down the 33 seconds that we can't group together, but the 1 minute that came from the 60 seconds we will regroup with the other measures that are minutes. So now we'll add together 1 minute and 45 minutes and 58 minutes. That adds to give us 104 minutes. But since we have at least 60 minutes that we could regroup, we're going to rewrite that 104 minutes as 1 degree plus 44 minutes. The 1 degree we can add to the other degree measures. So 1 plus 15 plus 22 is 38. So the sum of the two angles is 38 degrees, 44 minutes, 33 seconds. So what if we have a degree measure, but it's not measured in whole number degrees? It's measured in whole degrees and a decimal fraction number of degrees. So 31.62 degrees. How can we take the decimal fraction part of that and change it to minutes and seconds? Well, we'll start by thinking of 31.62 degrees as 31 degrees and another 62 hundredths of a degree. Now 62 hundredths of a degree would be 62 hundredths of 60 minutes. And if we multiply 62 hundredths times 60 minutes, we get 37.2 minutes. Now we still have a decimal fraction of minutes, but that's all right. We'll break that up into 37 minutes plus 2/10 of a minute. And now the 2/10 of a minute we can rewrite by remembering that there are 60 seconds in a minute. So 2/10 of a minute is the same thing as 2/10 of 60 seconds. And 2/10 of 60 seconds is 12 seconds. So in terms of degrees, minutes, and seconds, 31.62 degrees is the same thing as 31 degrees, 37 minutes, and 12 seconds. So that's the beginnings of our look at geometry. We have a lot more geometry to look at, but that's a lot of definitions and just some basics on degree measures.